All right, ladies and gentlemen, getting on with the program is our next portion. And again, our two very esteemed panelists. First, we have Miss Amy Vickers, and Amy has been a part of this committee since the inception, and both her and Mary Ann have been unbelievable as far as in the resources and commitment to the committee and the efforts that we've been able to achieve. But Amy is a nationally recognized water conservation and efficiency expert, engineer, and author of the award-winning Handbook of Water Use and Conservation, Homes, Landscape, Businesses, Industries, and Farms, and is the editor of Water Plow Press. She's a consultant for more than 125 U.S. and overseas water utilities and organizations, including a number in Connecticut and other New England states. And Amy is also the author of the first National Water Conservation Standard for plumbing fixtures that were adopted in the U.S. Energy Policy Act in 1992, now serving 7.9 billion daily, and most recently she is contributing chapter author in the Drought and Water Crisis, Integrating Science Management Policy, second edition, edited by D. Woodhouse, and is through the CRC Press and Francis Group. And she is education. She has a master's degree in engineering from Dartmouth College, a BA in philosophy, New York University, and more. So, Amy, thank you for being here. And Amy's partner in crime for this portion of the panel is no stranger to the water utilities in Connecticut, Mr. Jeff Ehrlich. And Jeff has worked in the water industry for over 25 years, and as Aquarion's water company's director of supply operation, he oversees the departments of 75 people that produce water for over 700,000 people in Connecticut. And the department operates 29 reservoirs, 9 water treatment plants, 60 pump stations, 100 wells, 70 water storage tanks, and Jeff has received his Bachelor of Civil Engineering from Villanova University and a Master's of Science from Rutgers University. So, Jeff, thank you, guys, for being here. So I think, without any further ado, I think Amy is going to kick this thing off. And ladies and gentlemen, please a round of applause for Miss Amy Vickers.
This is the clicker? Yeah. Great. Yeah. Great. Dave, thank you so much. And I want to thank Dave Romano, the Connecticut section, just putting this together in such a fabulous venue once again. Thank you for having me. Well, it's great to be here, and I have to say, last week I was in Snowbird, Utah, at the University's Council on Water Resources annual conference, and the first thing I said when I got up is, I am parched, because out in Utah you drink water all the time, so it's fun to be back in New England. I'm really kind of the warm-up act for Jeff, and I'm going to be kind of just giving kind of an intro to outdoor water use. Where are we? What are the trends? Quick overview on, what can we do? What do we need to do in outdoor water use efficiency? And then I'm going to turn it over to Jeff and really some of the incredible results they've gotten in Connecticut with their 2-day. Just briefly, a lot of you have probably seen this chart. The black bars are the trends in average domestic water use in this country. And if you looked at the most recent figures from the U.S. Geological Survey for 2015, we're now down to an average of about 82 gallons per capita per day, combined single-family and multifamily homes. And if you pull out of that what we know about indoor use, which based on studies done by people like Peter Mayer and others through the Water Research Foundation, we know that indoor water use in this country averages about 59 gallons per capita per day. It's usually 55 to 59 or so, roughly. So if we pull out that known indoor out of this sort of this average home use, we see we're using about 30 gallons per capita per day of outdoor water use, and that's still a lot. And what's interesting, if you look at the trend line on the chart, is that indoor water use is going down. I think a lot of us know this, but outdoor water use on average is staying about the same. And if you're a home that I would call a super saver, where your total average use is about 50 gallons per capita per day, all efficient fixtures, little outdoor use, combined indoor and outdoor use might be around 50 gallons. Some people would argue with me if that's really a reasonable figure, but I think we know with efficient fixtures today, for example, indoor water use can average only about 35 gallons per day. But in looking at these averages, it's really important to be aware of the fact that we're not all averages, and some people are highly efficient in their water use. They are what I call these super savers. They're far less than the average. And let me just tilt this screen a little bit. I can't quite see it. And yet, if you look at the top, user, the top 10% of users, often they're using anywhere from 35 to 40% of demand. And in this chart, again, this is just kind of a conceptual chart. Often, much of that is outdoor, and even here in New England. And so we have this disconnect. A lot of low users I call super savers, and again, these top users, top 10 to 25% of people who are really using the lion's share of outdoor demand. If we look across New England, and this is an example from Massachusetts, average reported, residential use, this is from Massachusetts in 2017, the most recent data, about half of the systems reporting that their average home use is 65 gallons per capita per day or less, and may surprise you to know that that's the statewide standard, and that is what at least half of the systems are reporting. But about half of them are also above that. Many of them are still below this threshold for the 82 GPCD nationally, but point being, there's still a lot of waste in the system, even when we look at averages. So how can we reduce outdoor water use? And I would say, after really 30 years working in the water conservation field, this is one of the most nagging problems. We have made a lot of progress, fixtures, et cetera, equipment and other aspects of water use, but we're still chasing our tail on this. So there's not one magic bullet. But again, if you look at systems across the country, and I think that you may see this in the handout from the Irrigation Association, about 50% of suburban and urban water use is outdoors. Much of that is irrigation. If you look at our total water savings potential, particularly at a site, very often you can reduce water use by half at many properties, often more at others. So how do we do this? Number one, and I think you heard this from some of the other speakers, we need to have more native and drought-tolerant turf and plants. Bottom line, that can quickly reduce irrigation needs. Healthy soils and mulches make a difference. Limited turf areas, I'll talk more about this in a minute. This isn't as relevant here in New England, but certainly in desert regions it is. But with limited turf areas, people will often have much less irrigation. So where there's turf, people will irrigate. So that's really where we see the savings, just by eliminating turf, there's less irrigation. So efficient irrigation systems and devices. There are many things we can do to reduce and to optimize our irrigation systems. Potential savings, if you look at the data, range anywhere from about 5% to 25%, and there is variation. And how do we get that? Well, we get that through rain and soil moisture sensors, efficient rotating sprinkler nozzles and heads, repairs, et cetera. But we're still stuck with this problem that we have a lot of inefficient and poorly designed systems. And if there's one thing I can say about smart controllers is that in some instances they are definitely saving water, there's no question. But it has been said by others that you can't put a smart controller on a non-smart irrigation system. And so even with smart controllers, which again, when they're optimized, can definitely save water, we don't always have well-designed irrigation systems. And I think one of the things we need, which I don't have on this slide, is we need to start thinking about irrigation systems as outdoor plumbing. Let's get them in the plumbing code, and let's have more professional standards on the design and maintenance and installation of these systems. So when you look at smart controllers, and some of the speakers this morning talked about them, how they're saving at golf courses, et cetera. Where you have professionals managing properties, I think we definitely are seeing some good savings. Some of the best savings I've seen are as much as 30%. In fact, last week I was talking with Michael Dukes, who's a researcher at the University of Florida in Gainesville, and Michael does terrific work looking at irrigation systems and efficiency and such, and he was saying, some of the properties he's looking at are getting 30%. But in talking with Michael, it's clear that, again, these are really professional sites. Some of the best also, I'd say 10%. Again, there's improvement. But one of the problems we're seeing with some smart controller installations is actually increasing water use. And there's a couple of reasons for this. One of the things you'll hear from water conservation managers is that the presets in some of these smart controllers are set to what we call reference ET. They're not adjusted really to the local climate as much as we believe that smart controllers are really sort of bringing in local climate data. They are, but they're also sometimes more working off of assumptions about how much water is needed even with those climatic conditions. So for example, a lot of people irrigate to what they call deficit ET. So let's say ET says, put 1 inch of rain a week on this turf. A lot of places you can use, let's say, only half of that, sometimes even 30% of that, and still have healthy green turf. So anyway, that's one of the issues with smart controllers. One of the things that's at least one utility is finding is smart controllers, and this is the Southern Nevada Water Authority, which has spent probably hundreds of millions of dollars in conservation in recent years. they're finding that properties that put in smart controllers, and again, this is just in Southern Nevada, I'm not saying it's here, they're finding a net savings of 5%. So when they look at the properties that save and the properties that have increased use, the net, quote, savings are 5%. And they have a question whether those savings will persist over time. So I'd also say that, though that figure reflects the technology within the last 5 years or so technology is improving, but I think, again, smart controllers can save water, but appropriate in some places, but they don't work everywhere. But bottom line, I'm a big fan of having permanent mandatory irrigation restrictions. I think we've seen time and again, whether it's drought or on a permanent basis, these can save. There are communities, and Jeff is going to be speaking in a moment about this, about Aquarian's experience, that have these permanent 2-day savings and realize tremendous savings from their schedules. Some are also 2-day. So I just want to give a little reference for where we are here in Connecticut. If you look at how much rain we get, particularly in the summertime when we have the highest demand for irrigation, we're getting anywhere from about 3.5 to 4 inches per month on average. Roughly speaking, again, this is theoretical. We get an average of about 1 inch a week. And even with on an average of 1 inch a week of rain, many people say, do we really need 1 inch of irrigation, whether it's rain irrigation for turf in New England? So again, conditions vary, needs vary, but we get a lot of rain here and we can utilize that more efficiently. Here's just a couple of examples. Again, this is from Florida. I'm not going to say it's exactly relevant to New England, but here's an example. Again, this is from Michael Dukes and University of Florida Gainesville research. Here's a site where they looked at actual irrigation. They put in about 70 inches of irrigation a year, and the actual need was less than 30 inches. So again, and they got 50 inches from rainfall. Rainfall isn't always when and where you need it, but I think this again shows us an example. We need to utilize rainfall more. We don't need to irrigate nearly as much as we do. This is just a quick excerpt again from research at the University of Florida, what they found on 2-day waterings. I think some of these numbers may correspond to what you'll hear from Jeff. They found 13% in, for example, Orange County, Florida. They also found that many people under irrigated, and we're very happy with that. And aesthetically, we're pleased with their lawns. But again, in this study, they found the high irrigators used a lion's share of that outdoor use, and that's really a waste. This is a slide from the city of Dallas, Texas. Holly Holt-Torres, who is the water conservation manager there. And if you look to where the red arrow is pointing, that's 2010, 2011, 2012. Dallas had several years of very bad drought. They finally said, enough of these temporary restrictions. We're going to go permanent on this. They now have a permanent mandatory 2-day restriction, 1 day a week during the wintertime. But you can see their demand is really going down, really to historically low levels, even as their population is increasing. This is an expert, again, I'm told this from actually the Alliance for Water Efficiency, and Marianne's going to be talking about this, a fabulous study they did on landscape transformation. It's loaded with facts and figures on this. This is a chart from that study. It's taken again from Southern Nevada Water Authority, and it's just an example of how water was saved per square foot when they tore out turf. And I think the message from this, and again, this is Las Vegas, it's not New England, but what they found is that over time, not only did people use less for their xeriscape or native landscaping, over time they used even less, because as the plant matured, it didn't need more water, and the savings grew. So I think that's a lesson for all of us. Part of my presentation is really talking about cost effectiveness of efficient irrigation. I frankly don't have a lot of numbers to share for you that are regional here, but I think if you look at, for example, Southern California, Southern Nevada, cities like Denver, Dallas, you'll see that their rebate levels are sometimes are very high, sometimes over $100, for example, for a controller. And again, the cost effectiveness for each of those rebate programs varies by system, but overall, I think what you'll see is that the payback is usually within 1 or 2 years, both for the customer as well as the utility, whether it's putting in a smart controller, rain barrels, rotating sprinklers, whatever. I want to start closing actually just by saying a few things and talking about the cost of having no drought restrictions. And, Marianne will talk about this, but one of the really big issues, which I think has been an impediment during drought and also normal time, is that water utilities, they want to do conservation, but if the customers reduce their demand, reduces revenue. And the Alliance for Water Efficiency has just done tremendous work, workshops, videos, planning materials, models on how to restructure your rates so that as your demand goes down, you will have the revenues you need, but you will also conserve. But anyway, this has been a big impediment, and this is an example from the 2016 drought that hit New England. This is from Massachusetts, where, you know, the story was that drought is killing this river, but if you look at the bottom here, water managers really waited to the last minute in this particular town in north of Boston to do anything. And so, you know, we really pay a cost for inaction, and I just want to remind us that, yes, drought happens to us, but we play a big role in the repercussions of that and how, quote, bad it is on the ground. And with that, I'm going to close, and I'm going to turn it over to Jeff, because he's got some great numbers to share with you. Thank you.